All right, hello, welcome back. Today, just going back over tangent, cosine, and sine, like I said I would. Wanted you to attempt it first. As I said, we're getting to the harder stuff, the trig. That's going to lead into what you're going to start doing in the next couple years of math. So yeah, I understand. I got a couple more emails, which again, I told you guys I love that. Just hey, this isn't going well. Can we go back over it? Yeah, absolutely. Weird times. I got no problem going back over stuff. Okay. Um, Now, today I skipped up to 52 because I thought the first part was pretty easy. I shouldn't say easy. I thought that the questions I was getting and people when they were talking, it seemed to be not with the issue of like setting up, of knowing opposite over hypotenuse when they gave you all three numbers. This is when the IXL starts to get a little tricky with you, okay? Where it says something like the tangent of E, so we need opposite over adjacent, but we don't have the adjacent, okay? Now, good news though. Like I've always said in geometry, you got to remember everything you've ever done. And yeah, that's a little bit of a daunting task, but this is one of the most famous theorems out there, right? If we have a right triangle and we're missing a side, we can find it by Pythagorean theorem. So I would come over here and I'd go 15 squared plus 17, or sorry, 17 is the hypotenuse, plus b squared equals 17 squared. Now I can find that missing side. Okay, so here I'd go through and I need to plug all this in. And I can't do that off the top of my head, so I'm going to plug it in my calculator. So I end up with 225 plus b squared equals 17 squared, which I need to do. 17 times 17, 289. Okay. Last step here would be to subtract, sorry, not last step, subtract 225 from 289, move that across, and we get b squared equals 64. So they're going to be nice to us on this one and not make us work with radicals, okay? Because we take the square root of 64, we get 8, right? That's how you get rid of the b squared piece. You go square root. So b is 8. Now we're back to what this IXL started as, which is just plugging it in. So tangent of E opposite 15 over 8 over adjacent. Okay, and we're good. Okay, so now find the tangent of W opposite over adjacent. So now they're adding yet another trick. They're going with a radical here. Okay, when in reality they're not changing anything from the last problem, because radicals you just need to learn to treat them like numbers, do the things that we've talked about, how to get rid of them, how to cancel if they're in the denominator. So here tangent of W would be opposite over adjacent, so I have that. I don't have opposite, so I'm going to do square root of 7 squared, which I'm going to skip a step. I'm going to know that that's going to cancel and just be 7 plus b squared equals c squared, which is 36. Okay, subtract the 7, I get b squared equals 29. Equals 29. Okay, so then I take the square root of that and I get b equals the square root of 29. And if we want to make our work simpler, whenever we get a radical, we want to say like, okay, can I clean up that radical in any way? So let's see, square root of 29, are there any clean squares in there? Nope, it's pretty much stuck as it is. So then we'd go and we'd say, okay, so now we can do the tangent. So the tangent of W, sorry, my trackpad's really not letting me write real well right now. Tangent of W is going to be opposite, so square root of 29 over square root of 7. And this is where we talked about last lesson. That's a good answer, but we have a radical in the denominator. So I need to get rid of it. So times it by itself. So times the square root of 7. Times it by itself. Times the square root of 7. What we end up with is the tangent of W equals Square root of 29 times the square root of 7. I can multiply those out. So 29 times 7. So I get the square root of 203 over regular 7. Now I need to make sure, is there anything in 203 that I can simplify down? 203, I can test it just by dividing by the squares I know. So I did 203 divided by 4. You also can do, we talked about, like, you can do the branch method where you just break down and see if there's anything left. Okay, either way, it doesn't look like anything clean is going to come out of this. (203 divided by 36). Nope, I don't believe so. So I think that's our final answer. So square root 203 over 7. And we're good to go. Okay. That should get you to 70. Otherwise, the only thing they do different as they go on past 70 is like mixing these up, but that doesn't change anything. That just means you have a whole number out front and then a radical with it. Okay. You still would do the Pythagorean theorem to find it. You still would need to simplify any radicals in the denominator, but it all starts to look pretty similar. Don't freak out because of radicals. Don't freak out because things look a little different or messy. Now you're getting into things that will be messy, okay? Otherwise, hopefully this helps a little bit. If you have any questions, please continue to let me know. Otherwise, enjoy your Monday.